So the Bills took home the win against the Jaguars yesterday, and they're moving on to the divisional rounds. And today we're talking about two potentials for an East Coast snowstorm. So let's dive right into this one because this is going to be an interesting one, an interesting setup here. So let me show you. So here is the setup that will be responsible for bringing not one, but two chances of snow to the East Coast. One comes late next week, Thursday and Friday, and the other comes late next weekend around Sunday. So what we're going to have is we're going to have this dip in the jet stream across the eastern half of the country, which is where I'm showing you right here with my cursor. And that's going to allow this cold air to drain southward out of Canada. It's not going to be Arctic air, but it will be cold enough to support snow. So we're also going to have energy diving southward. What we need for an East Coast snowstorm is we need the southern energy that will be down here to get out ahead of the main trough. And what we want is we want either a neutrally tilted trough or a negatively tilted trough. And that would guide the storm up and along the coast in order to bring that East Coast snow. But right now the question is, does it storm right up the coast or does it go out to sea? That's the million-dollar question at this point, and I don't have the answer for you, but we're going to talk about the setup here. So let's take a look at what the models are showing. We'll look at both the GFS and the European here. So let's talk a little bit more about the setup here. And what we're going to have is we're going to have a storm passing to the north through the middle part of the week here, which I'm showing you right here as I'm moving along. And this will bring another shot of cold air across the central and eastern parts of the country. And I want you to notice, look how far south that 540 line gets. So the cold air is going to be in place. And we're also going to have this high pressure sitting over the upper Midwest, which with clockwise flow around the high, you're going to help to drain that cold air southward out of Canada. And then what we're left with, and this is a key, this is what we're left with. We're left with a frontal boundary that's going to be draped along the East Coast, down, extending all the way south into the Gulf. And that's going to set up a baroclinic zone along the coast, which would add fuel to any storm that's able to ride up and along that frontal boundary and go up the coast. So if a storm is able to do that, you have added energy there due to a baroclinic zone. You have this frontal boundary that's going to be draped along the East Coast, extending all the way down into the Gulf. All right, so let's take a look at the upper levels now. And I want to show you, here is the energy that is going to be responsible for bringing that first potential for snow along the East Coast. And the million-dollar question is, does this energy get out ahead of the main trough in order to form the storm? And do we get a neutrally tilted or negatively tilted trough in order to guide that surface storm up the coast? Or does this energy coming in from the west result in this energy being pushed more out to sea? And right now, I'll show you what, it's going to be a very close call, very close call. But right now, the models are favoring an out to sea solution. And it's due to this energy right here coming in. It's going to kind of kick this out. As of right now, that's what the models are showing. But there's small differences in the upper levels make huge differences at the surface. So right now, I'm not throwing out the potential because the potential is still there for an East Coast snowstorm. It's just the models aren't showing it right now. They're showing that energy along the east getting kicked offshore, and then the storm stays mostly offshore. And I want to show you what the surface looks like here because that's important too. I'll show you what the surface looks like. And here's what it looks like at the surface. You see the storm right out here. This storm is just off the coast, just off the coast. So New England might get hit, might get a glancing blow with this solution, but most of the storm is offshore, but it's a very close call. I mean, it's very close call. Just a small differences in the modeling can make a huge difference at the surface. Like I said, what we want is, let me go back to the upper air map here just so I can show you. What we want is we want this main trough to either gain a neutral tilt, or what you want is a negative tilt. The negative tilt is preferred in order to get that storm, the surface storm, to be pushed up the coast because you get this southerly flow. If you have a negative tilt, the axis of the trough would be like this, and you'd get the flow in the deep levels coming out of the south or southeast, and that would drive the storm back and up and along the East Coast. But what we have here, we don't really have that. It does start to gain a neutral tilt by the time it gets offshore, but over here you get most of the flow heading out that way. So it's going to take the storm offshore. Plus, you have this energy coming in that seems to want to kick that energy just offshore and keep the storm just offshore. And honestly, at this point, I don't know what to believe. I mean, it's hard to say at this point. I could see it going either way, but either way it's gonna be a very, very, very close call in terms of an East Coast snow. But right now the models are favoring the out to sea solution. Let me show you what the European is showing. So here is the European model, and it kind of has a very similar solution to what the GFS is showing. You get this, right now it's a positively tilted trough, and you get this energy. This is what you want to get out ahead of the main piece in order to be pushed up the coast. But what we have is instead, it starts to become neutral, but you also have this energy diving down south that seems to want to push this energy just offshore. And then when it's just offshore, you see it becomes a negatively tilted trough. So then the storm wants to move up towards the coast, but it's just offshore. It is just offshore. Let me show you what it looks like at the surface so that you can see where this storm is placed, but it's just offshore, just missing the East Coast. So it's, like I said, it's going to be a very, very close call in terms of an East Coast snow. I mean, up in New England, you might get a glancing blow with this solution, but it's not going to be a big, big snowstorm if this solution is correct. Now, I want to show you the second chance of snow, because the second chance of snow comes in on Sunday. I think the first chance is the best chance. Second chance there's still a chance, but I don't think it's as good as the first time. So let me show you on Sunday here. So here is the second chance of snow that comes late in the weekend on Sunday. And this is the energy that we're going to be dealing with then. And what you want is this energy down here to get out ahead of this main northern trough. And does it seem to do that? Not at this point. It does not. And then you also, again, have this energy diving down south out over the upper Midwest that seems to want to push this energy just offshore. And then you get a negatively tilted trough now, but it's offshore. And I'll show you what it looks like at the surface, because it keeps the storm offshore again. And it's just similar to, I mean, you might get some snow along the coast, but most of the storm stays off the coast, and you don't get a whole lot of snow out of that setup. But it's another very close call. I think it's going to be a very close call, and small differences in the upper levels make huge differences at the surface. Let me show you what the GFS is showing, and we will end the video there then. So here's the GFS. You get this energy diving down south, and you get this trough to set up. You get this jet stream that dips down south. You get this cold air that's in place in the north, and you get this energy here. You want it to get out ahead of the main trough and be guided up the coast. But look at it again, it seems to be pushed out to sea by this energy coming in from the west. But then also you have more of a positively tilted trough as it's coming in, and it just starts to get neutral. And then when it's off the coast, that's when it becomes more negative. But the energy does stay more off the coast. And then at the surface, you see it stays offshore here. I'll show you what the surface map looks like. And there it is, just offshore. Another very close call, but it's too hard to say at this point. It's only Monday. We still got a few more days to watch the model trends and see how they change over time. So stay with me throughout the week. I will keep you guys updated. If anything changes at all, I will let you guys know. Thank you guys for watching. Hope you guys enjoyed, and make sure to hit the like button and subscribe to show your support. Thank you.